Okay, welcome back. In this video, we're gonna try to solve the following limit. Sine x minus tangent x over x cubed. So we wanna find the limit as x goes to 0. The first thing that we do in this case is to just plug the 0 and see what happens. So when we plug the 0, to have the sine of 0 is 0, tangent of 0 is 0 over 0 cubed, which is 0. So we have 0 minus 0 over 0. That means we have the 0 over 0. So we can't decide. This is a form that we can't conclude any result from it. Okay. Sometimes we need to do some modifications. But if you want to solve this problem, I can give you some hint here. Okay, so try to write the tangent in function of the sine and cosine, okay, and use the fact that the limit of sine x over x is 1 when x is close to 0, and also use the fact that the cosine 2x is 2 cosine squared x minus 1. It's 1 minus 2 sine squared of x. And since we don't have 2x, we just have an x. So solve here to get cos x is 1 minus 2 sine squared x over 2. And do some manipulation to find some easy to deal with limit. A limit that maybe we know or maybe that we are familiar with. Okay, you can at this moment stop the video and try to use these hints here and see what you can get. Okay, let's jump to the solution now. Let's write this formula in a different form. Okay, so before we take the limit, let's just try to simplify sine x minus tangent x over x cubed. So we write it like this. Let's write tangent. So tangent x is sine x over cosine x. Let's use this one here. So we get sine x minus sine x over cosine x, everything over x cubed. Okay, when we simplify, we get sine x cosine x minus sine x over x cubed times cosine x. Okay, here there is a factor in common. Okay, so sine x, let's take it out. So you get sine x factor of cosine x minus 1 over x. Okay, let's split this x cubed. Okay, so we have x times x squared times cosine x. Okay, we see that we have something that we know now. So sine x over x, we know that the limit is 1. But this one here, cosine, when we plug the 0, we get 1 minus 1, which is 0 over 0. We still have the problem. Okay, let's try to simplify this one. So here, we're going to use this formula here. So cosine x is 1 minus 2 sine squared of x over 2. So when we take the minus 1 here, so we get cosine x minus 1, we get minus 2 sine squared of x over 2. So let's use it here. So we get sine x over x times minus 2 sine squared x over 2 over x squared cosine x. Okay, sounds good now. Okay, let's write it one more time. So sine x over x. So here we have this square here, but we have x over 2, but we don't have it here. So we divide by 4 and we multiply by 4. So we get 1 over 4, okay, times minus 2 sine x over 2 squared over x over 2 squared times 1 over 1 times cosine x. Okay, this is just a manipulation. Okay, so this is x over 2. So what do we know here? So here we know that this is 1, and 1 over cosine of 0 is 1. Okay, and this limit here, 1x goes to 0 is 1. So we had minus 2 over 4, which is minus 1 over 2. Okay, so we got the limit. So here we just write the limit of sine x minus tangent x over x cubed is equal to the limit 1x goes to 0 of, let's take the 1, 4 outside, sine of x over x times, let's take the minus 2 here outside, so we get minus 2 sine x over 2 squared over x over 2 squared times 1 over cosine. Okay. Okay. So now we know these limits. We know all these limits now. They are all clear for us. Okay. So we know these limits. So when x goes to 0, what do we get here? 1. So this is 1, this is 1, and this is 1. So we get minus 2 over 4, which is minus 1/2. So the limit is minus 1/2. Okay. Try to rework this problem. Okay, so the limit is minus 1 over 2. So without these formulas, without this limit, without this manipulation, without this change here, we couldn't have solved this problem. Okay, so we are using our trig properties to solve this problem. There is another way, but it's longer. So we use L'Hopital's rule. So when we did with calculus, we're gonna solve this one here. Okay, but for now, we just remember this one here, and remember this change when you do like x over 6. You need the 6 here, so you just multiply and divide by 6 to get the 1. To get 1 over 6. Okay, this one here is very famous. Okay, so remember this. This is the definition of the tangent. This is just the change. Okay, so here we have 2x, but when we do x, we change x over 2. Remember, 2x, and here we divide by we have 2x. There is another x here corresponding on the right side, but x, there is an x by 2. Okay, so this is very important. If you have x over 2 here, you do x over 4, or x by 3, it's x over 6. Okay, so this is very important to know and to remember. You will see them everywhere, like in AP calculus, and maybe some problems. When we do problems, when we do applied problems, we're gonna see them over and over again. Remember, just write down the definitions and remember these limits, and see other videos for the proofs. If you have any questions, please ask. So the limit that we found is minus 1/2. If you see any mistakes or any problems, please comment in the comment section. I'll be more than happy to help you with that. Thank you.